Hello. We're continuing our work with straight lines, and we're mostly going to do more of the same sort of stuff we did last time. So we're going to look at problems involving straight lines, the equations of them, and how to find missing points and so on. But there's another way we can express a straight line. So let's consider this. So I'm going to draw a line again, and again a generic line, as so. And again, consider 2 points on the line, right? And so we would call that, if that's point 1 and that's point 2, say. Remember, we call the gradient of the line. M is change in y, so that's y2 minus y1 over the change in x, which is x2 minus x1, at the points 2 and 1, okay? Now, what if instead of having the point 2, what if we just call it a generic point xy? Okay, so what if we find the gradient between a given point, which is x1, y1, and the point xy, instead of just having x2, y2? That's still perfectly legitimate, because no matter what point we pick on the line, any 2 points on the line, the gradient will always be the same. So actually I can choose any point, not just a particular point, right? I can actually choose any given point xy. Okay. So the gradient between a given point x1, y1 and any point on the line xy. Okay. So what would that going to look like? Instead of y2, could we just call it y? And instead of x2, we can just call it x. Okay. So it's a general point xy, the gradient between that and a particular point 1, okay? Now, so have this equation then, m is equal to that. Well, what if then, to get rid of the fraction, what if I then times by the denominator? What if I times both sides of the equation by x minus x1? Okay? Then I get m lots of x minus x1 is equal to y minus y1, or I can write it the other way around and say y minus y1 is equal to m lots of x minus x1. And that is actually, turns out, another equation we can express a straight line in. So we looked at last time, we had y is mx plus c, a classic way of expressing a line, my preference as well. And we called that, you might see it's called slope-intercept form, which obviously is because there's a slope, which is the gradient, and the y-intercept, the intercept, right? But we got an alternative, which is this formula, right? Which I've sort of just derived, right? So we call that a point slope form. Okay. Instead, again, you don't necessarily need to remember that. It's just you might see it floating around somewhere, and these equations do have names. But what I guess the good thing about this point is, you don't necessarily need a y-intercept, because remember, y-intercept is the particular point on an axis where it crosses through the y-axis. If we don't have that, then actually instead you might opt for this equation, because all you need with this equation is the gradient, and you just need 1 point x1, y1, okay? Then you can substitute x1, y1 into here, and m here, and then therefore you get an equation of a line in that way as well. We won't have to faff about finding a y-intercept. However, these two equations are equivalent, and one's not objectively better than the other. I prefer this form because you can really directly see what the gradient and the y-intercept is, because that is quite handy. But like in order to use both equations, you still need the same information. So one's not really better than the other. But we're going to use this equation then that we just worked out, right? The point slope form. Okay, and that's really it with this. So let's look at some examples. So example 6. Find the equation of the line with gradient 5 that passes through the point 3, 2. So again, we have the other form, y minus y1 is m lots of x minus x1. Okay, well then m is the gradient, which is going to be 5, and also we're given the point 32, which means that x1, okay, so x1, y1 correspond to a given point that we know on the line. So x1 is this x coordinate 3, and this y coordinate of 2 would be y1, okay? Then we could just substitute all that in. So then therefore y minus y1, which is 2, is equal to m, which is 5, lots of x minus x1, which is 3. Okay, and that is an equation of a line. It doesn't say to simplify the equation anyway. It just says find the equation, find an equation, right? Don't need to simplify it, just give a equation. So we could leave it there. So it is a bit quicker than finding the y-intercept because obviously this is not a y-intercept point. Okay, so we'd have to do some extra work to substitute the point in and then find out c. But in this way we can just directly put the information in. So this equation is slightly quicker in this particular case. But if we were to expand it, we can get it back in y's mx plus c form. Let's expand the bracket. So y minus 2 is 5x minus 15. Then I can move the 2 to the other side. So then y is 5x plus minus 13, because minus 15 plus 2 is minus 13. And there we are. So these two are sort of equivalent, right? So these are the two different ways we can express a line, okay? But yeah, so you might find one form is handier than the other, but I personally tend to stick to y's mx plus c form, and also I've not really seen an exam question that forces you to use one form or the other. They might say give your answer in the form like y's mx plus c, but but they don't explicitly say you must use this method. Basically, as long as you find the answer looks a certain way, you can use whatever you want essentially. But yeah, cool. Let's have a look at this example. Find the equation of the line that passes through the points 5, 7 and 3 minus 1. Okay, well let's stick with the other equation we just learned again. So y minus y1 is m lots of x minus x1. Well, again, we need a point on the line, so that'd be x1, y1, but we also need m. But we don't know what m is, we don't know what the gradient is just yet. But how do we work out the gradient? We looked at that last time. Isn't m the change in y the change in x of 2 points? Well, we have 2 points here, so firstly the change in y, well let's take the second point as the second value. So y2, the y coordinate is minus 1 there. Then change in y, so then take away the other y value of the other point, so minus 7. Then change in x, so of the same point there, 3 is the x value there. Take away the other x value of 5, and that give me my gradient. So I can simplify this to get minus 1 minus 7 is minus 8. 3 minus 5 is minus 2, and that simplifies down to positive 4. Okay, cool. Okay, well then I found my gradient now. I just need a point. Okay, so point x1, y1. Well, I can just call that. Well, I have 2 points, so you can take your pick actually. Let's just use 5. Let's just use 5, 7, because that's x1, y1 that we use for the gradient. Say, but it doesn't matter. We take that's 5, 7. Therefore, x1 is 5, y1 is 7. Okay. Then I can just substitute all that into this equation of a line to get y minus y1, which is 7, is equal to m, which is 4. Lots of x minus 5, okay, and that's x1 there. And there we are. So it doesn't ask to simplify it or give my answer in a certain form, so that is fine. That is an equation of the line, okay. You could simplify it, you could give it another way if you want to, it's up to you, but that we don't need to do any more work, so that is my answer. Cool. Example 8. The line y is 3x minus 9 meets the x-axis at the point A. Find the equation of the line with gradient 2/3 that passes through point A, and write your answer in that form. Okay, well, when questions like this, when it starts to get a bit like visual, a bit graphical, a bit geometric. So it's talking about crossing an x-axis. So let's visualize what that means. So let's draw an axis then, because it's talking about an x-axis. So Okay, so it's telling us this line here meets the x-axis at A. So that line, a positive gradient, so passing through -9, it's going to look a bit like that, okay? And it's passing through the x-axis at A, okay? So that would be the point A there. Then it says find the equation of a line with gradient 2/3 that passes through A. So that's a different line it's talking about. So that's the line y is 3x minus 9. It's talking about another line, say this, that also passes through A but has a gradient of 2/3. So it's a different line. We need to find that line. Okay, well, it is a good idea first to find out what A actually is. Where exactly does it pass on the x-axis? So A has a coordinate, because it's on the x-axis, it's going to have the point x, 0, okay? Y is going to be 0 at A, as it's on the x-axis. Okay, well A, we know is on this line here. The line crosses at A, so A has to lie on this line here. So Y is 3x minus 9. We can find x in A. We can find the x coordinate of A, okay, by substitute y 0, because at that point y 0. So if y is 0, then 3x minus 9 is equal to 0. But then 3x is equal to 9, then x is equal to 3. Therefore, we found our point. A is 3, 0. Okay. Okay, well then we need to find the equation of this other line then. So we know we have a gradient of 2/3. We could let's use the form we talked about. So y minus y1 again is m lots of x minus x1. Well, we know the gradient is 2/3. So we know m is 2/3 of this other line. And we also know a point, because we've worked out A is now 3, 0. And that also, we're told, that line also passes through A. So we have the point that x1 is 3, y1 0. Therefore, we can substitute all this in to get y minus y1. So if this is x1, y1 for here, then y1 is 0, and m is 2/3, and x minus x1, x minus 3. There we are. Okay, well, it is asking us in this case to write this answer in a particular form in this one, so we do need to simplify this. So, let's simplify, let's expand the bracket. So, y minus 0 is just y, and that's equal to 2/3 of x minus 3 times 2/3. That's 6 over 3, which will go down to 2, okay? There we are. Well, that's in y's mx plus c form. So again, they are equivalent, the two types of line equations. Okay, but we need it in this form. Okay, so we need, so if we look at it, everything needs to be on one side equal to 0. So let's do that then. Move everything to one side. So let's say we have minus 2/3 x plus y plus 2 equals 0. Okay. Well, there we are. It resembles this. There we are. It resembles this form. But pay attention. Also, it wants the coefficients a, b, and c to be integers. Well, we have a fraction here. So that's not an integer. So what do we do there? Well, we can get rid of the fraction by timesing everything by the bottom. So times by 3, okay, to get rid of the fraction. Because then minus 2 over 3 times 3 is just minus 2x. Then plus 3y plus 6 equals 0. And there we are. Cool. That is our equation. Cool. Okay, let's have a look at this example. The lines y is 4x minus 7 and at 2x plus 3y minus 21 equals 0 intersects at A. The point B has coordinates minus 2, 8. Find the equation of the line that passes through points A and B. Okay. Okay, so firstly I'm given that these two lines intersect, okay, and they intersect at A. How can I find their intersection? Well, I can equate them together. So y is 4x minus 7 and 2x plus 3y minus 21 equals 0. Well, it's like simultaneous equations. If they cross each other, the two lines, they equal each other, which allows me to find the point. So then I'm going to substitute y from here, in this equation into here. So therefore, 2x plus 3 lots of 4x minus 7 minus 21 equals 0. Okay, so just replaced y with this whole equation here into the other equation down there. Then I can expand it, so then 2x plus 3 times 4x is 12x, and then 3 times minus 7 is minus 21. Minus 21 again is 0. Then I get 14x minus 42 is equal to 0. Then that means 14x equals 42. So then x is 42 over 14, which is 3, I believe. Yes, there we are. Cool, so then that's my x point. So then I need the y value as well. Well, then I can find y by substituting x back into either equation. So therefore y is going to equal 4x minus 7. And that's going to equal 4 lots of 3 minus 7. Which will give me 4 times 3 is 12 minus 7, that would be 5. Okay. Therefore, xy is 3, 5. So that means the point A, that the intersection point, is going to be coordinate 3, 5. Cool, so we found A then. Then it said, then we have a point B as well, which is minus 2, 8. That's given. Find the equation from the line that passes through both points. So it's going to pass through A and B. So again, this line again is going to have be written. Well, we can. I'm going to use y is mx plus c now. I'm going to spice it up. This line that passes through these 2 points here, the different line to these 2 lines. Okay. The line now that we want that pass through the 2 points, I'm going to just call y is mx plus c. It's a very good idea to just do that. If you need to find the equation of a line, you can just start from there, okay? Then we need to find m and c, the gradient, the y-intercept, okay? Well, the gradient, first of all, well, that we got 2 points, so the gradient between them is just changing y, changing x again. So let's take b as the second point, so 8 the y minus the other y, which is 5. And then take away the x, so minus 2, take away 3. That's going to get me 8 minus 5 is 3. Minus 2 minus 3 is minus 5, so it's going to be minus 3 over 5 as my gradient. Cool. Okay, but then that means that y is minus 3 over 5x plus c. But then I need to find c. Well, none of these are a y-intercept, so I'm going to need to substitute a point in to find c. So I'm going to say let's substitute a in, right? A 3, 5 into this line. Then y would be 5, so 5 is going to be minus 3/5 of x. That's going to be minus 3/5 of 3 plus c. Then if I expand that, I get 5 is equal to minus 9 over 5 plus c. Therefore, c is 5 plus 9 over 5. That is, you put in the calculator, 34 over 5, okay? Okay, well then that means that, I don't have much room, but that means this equation then, y is x plus c, y is now minus 3/5 x. So again, that's the line we have here. Now we have to c, so that's 3 over 5 x plus 34 over 5. Cool, okay. But then he wants my answer in this form. Again, everything equal to 0, where they're all integers, all the coefficients. Okay, so again, I need to move everything to one side, so I get 3/5 x plus y minus 34 over 5 equals 0. Then I need to get rid of the fractions. Well, they're both out of 5, the bottom number, the denominator, so I can times the whole thing by 5 on both sides, to then get 3x plus 5y minus 34 equals 0. And there we are. That's that form of the line where all the coefficients are integers. There we are. Cool. Okay. I did eat into this space a little bit. But let's have a look at this example now then. it says the straight line L passes through 7a5 and 3a3. The an equation of L, that's interesting, an equation of L is x plus by minus 12 is 0. Okay. Find the values of a and b, so a in the coordinates and b there. Okay, so again, with examples like this, a bit of problem solving, just it's a good idea to work out anything you can work out, right? So what's immediately screaming to me perhaps is I've got 2 points, so maybe I can work out a gradient. Um, uh, or I could substitute both points in into this equation here. Um, um, I don't know. I'm spoilt for choice of how I can solve this. Yeah, I feel like most people have. I don't know. I'm going to substitute the points in. So I'm first going to say sub 7a5 into the line. So I'm going to say x. Well, x is 7a. So I'm going to get 7a plus by. So b lots of y is 5. So I'm going to get 5b. Minus 12 equals 0. Okay, well then that's just equal to 12, isn't it? If I move the minus 12 to the other side, I get that. Okay, then I'm going to substitute the other point in. So 3a3 to then get, because both points have to lie on the line, that allows me to substitute points into the line, by the way. So then x plus by, so x is 3a now, plus by, so y is 3, so I get plus 3b. And that's going to equal 12 again, because it'd be minus 12 equals 0. But then I could just add 12 to both sides to get equal to 12. Well, hang on. Look at these two equations then. Well, isn't that simultaneous equations? If I label that equation 1 and 2, I can then solve these for A and B simultaneously. Okay, so let me rewrite this then. So I have 7a plus 5b is equal to 12. 3a plus 3b is equal to 12. Okay. And that's 1 and 2 again. Okay. Okay, well, again, we covered how to solve these sort of simultaneous equations in chapter 3 with equations. And I can use elimination or substitution. I'm going to use elimination in this case. Again, I'm spoilt for choice of how to solve these. But yeah, okay, elimination. So elimination then. It's good to practice old skills as well. So elimination, I need to basically eliminate one variable by matching the coefficients of one particular variable on both equations. So for example, I want, let's eliminate a. So I have 7a up here and 3a on the second one. I need both both equations have the same coefficient of a, so I'm going to need to scale both equations separately. Well, I can just times by the common lowest common multiple, right? So what goes into 7 and 3 is 21, so I could just times the first equation by 3, because then 7 times 3 will get me 21. So 21a plus 5 times 3 be 15b, and that's going to equal 36. Then the second equation, and then need to times by 7, because then 3a times 7 is 21 again, and then 3 times 7 would be 21b, and that's going to equal 12 times 7, that's going to get me 84. There we are. Now with this, what I've done here is I can now subtract both equations. Because then 21a will cancel out the 21a, so then I'm left with 15b take away 21b, which is minus 6b, and that's going to equal 36 take away 84, that's going to get me minus 48. Okay, that means therefore b is going to be minus 48 over minus 6. So that will get me 8, positive 8. There we are. So we've got a b value of 8. Okay, well then I found B, then I can find A by substituting B back into either equation. So that means then I'm gonna then we can say that 7A plus 5B, so 5 lots of 8 is going to equal 12. If I simplify this, expand it, I get 7A plus 5 times 8, which is 40, is equal to 12. So then 7A is going to equal 12 minus 40, which is minus 28. Therefore, A is minus 28 over 7. That should be minus 4. There we are. So therefore, to summarise, A is minus 4, B is 8. There we are. Good, good, good. There we are. Come. Okay, final question then. Final question. So, yeah, there are multiple ways of doing this. These sort of questions, but yeah, just do what feels comfortable to you. For me, it made the most sense. I got an equation, and I got points on the line, so I could just substitute the points in to see what I can work out, basically. And there we are. Cool. You could alternatively perhaps find the gradient, and then you could find physically what the equation on the line would look like, and say like y is mx plus c, or y minus y1 is m lots of x minus x1. Then you could compare it with this equation to find a and b that way. But I prefer, I guess, probably took the more tedious route, longer route, but we got there. Anyway, question 12, final one. We have the line y is 3x minus 5, and it meets the x-axis at the point M. The line y is minus 2/3 x plus 2/3 meets the y-axis at the point N. Find the equation of the line joining the points M and N, give your answer in that form. Again, there's a lot of geometric stuff going on. So let's kind of visualize what's going on. So this line, first line, 3x minus 5, so it's going to look about there. Look like that perhaps. It meets the x-axis at M, so that's going to be point M, and that's going to be y is 3x minus 5. Then we have this other line, minus 2/3 x plus 2/3, and it meets the y-axis at the point N, so it's going to look something like that. Okay, and we're told the here at N. Okay. Let me make that a bit clearer. It doesn't have to pass through N. There we are. That's a better visualization of it. So that's the point N, the y-intercept, right? And that's the line y is minus 2/3 x plus 2/3. You don't have to, write everything out. I'm just giving a sort of detailed sketch. But the whole idea is one line crosses the x-axis at M, the other line crosses the y-axis at N, okay? Then we need to find the line between N and M. Okay, so firstly, again, lots of stuff going on. Just work out bit by bit work out what we can work out, and then go from there. Firstly, I'm going to find the point M then, okay? Well, M, if it's on the x-axis, it's going to be x0, because y would be 0 on the y-axis. On the x-axis, sorry. But also know that M lies on this line here. So I'm going to sub the point x0 in, right? Sub the coordinate x in, m in, sorry, into this equation. So y would be 0, and then 3x, well, that's just x minus 5. Then I can find the x coordinate by then saying 3x is equal to 5, x is equal to 5 over 3. Cool. Therefore, M is the point 5, 3, 0. There we are. Then I can do the similar sort of thing for the other line to find N. So this time N is a y-intercept. It's on the y-axis, so it's going to have the point 0, y, because x is 0 on the y-axis here, right? So there we are. So again, and then this point N now lies on this line here. Okay, so y is minus 2/3 x plus 2/3. Again, I'm going to do a very similar sort of thing, a substitution. So I'm going to sub the point 0, y in. To then get my y is just y, that's what I want to find. The y coordinate is minus 2/3 of x, which is 0 plus 2/3. Well, that means y, that this whole thing goes to 0 because I'm multiplying by 0, so I'm left with 2/3. Therefore, the point n is 0, 2/3. Cool. Then it's asking me to find the equation of the line between the points m and n. So I can, well, let's go back to this form, right? Y minus y1 is equal to m naught of x minus x1. We can write an equation of the line as we did earlier in this form. You could do it in mx plus c form if you wish, but let's wrap with this form here. So first you need the gradient, m. Well, we have 2 points again. So between these 2 points, the gradient is changing y and changing x. So let's take n as the second point. So that's 2/3. So take away the other y coordinate, which is 0. Then I have the change in x. So then I have to take this as 0 first. Because if n is the second point, then remember I have to match the order and when I'm taking the difference in y and x. So 0 comes first, and I take away with the other x coordinate, which is take away 5/3. But that simplifies to 2/3, take away minus 5/3. Okay. Okay. Now that's quite nasty, isn't it? Fractions and a fraction and a fraction. You could put that in the calculator, if you want to. I'd probably recommend it, but if you are, this sort of situation just come up from time to time. Some of your answer at some point you're working will have fractions in a fraction. You can deal with that by actually just recognising this is take the top bit, so that's a fraction of 2/3, the numerator. Then this whole fraction is just a division, isn't it? Remember, a fraction a over b is same as a divided by b. Okay, so I can divide it by the denominator, which is this other fraction here. So divide by minus 5/3. That's just divided two fractions. So then I can do KFC, keep flip change, keep the first fraction, change the sign to times. Then I flip the fraction to minus 3/5. But then I can just times the fractions to get minus 6. 2 times minus 3 is minus 6. 3 times 5 is 15. Okay, and then I can simplify that to minus 2/5. Okay, there we are. Cool. So that's our gradient m. But yeah, you could have just put that in your calculator if you wished. But yeah, it's good to practice algebra skills or arithmetic skills. Anyway, so then I need well, for this form here, y minus y1 is x minus x1. I need a point. I need a point on the line, right? I need a point that is x1, y1. So I need to find any point at all that I know is on the line. Well, I know m and n, these two coordinates on the line. Well, let's just take m, which was the first coordinate, right? To be x1, y1. Therefore, we'll substitute m and all this in to this line here. I therefore get y minus y1, so y minus 5/3 is equal to m, which was now minus 2/5, which we worked out, of x minus x1, which is, oh no, what, no, sorry, y1 is the y coordinate, sorry, that'd be 0, there we are, and x1 is 5/3, there we are. Cool. Okay, well then, that's an equation, but it wants us to write it in this form again, where all the coefficients are integers. So I need to then sort of rearrange it a bit, expand it. So then I get y minus 0 is just y. So then that's minus 2/5 x minus 2/5 times by minus 5/3. I'd probably do that in a calculator to get positive 2/3. Okay, if I expand the bracket. Okay, well then I need to move everything to the left to one side to make it equal 0. Therefore, I get 2/5 x plus y, take away 2/3 equals 0 if I rearrange it. Okay, well then lastly I need to get rid of the fraction to make everything integer. So no fractions. Okay, we'll have a 5 here and a 3 there. Okay. If I then times by 5, I'm going to get 2x plus y, but then I'm going to get minus 10 over 3. So it's still a fraction. Now I could then consequently times it by 3, but I don't have much room here to do it again. Or alternatively, I could again just times by the number that goes into both 5 and 3, which is the lowest common multiple. That would be 15. Okay, so then I can times by 15 to get rid of both fractions at once. So then 2 over 5 times x is 2/5 times 15 is going to get me 6x. And then plus 15y, times it by 15, then times minus 2/3 by 15, I get minus 10, and that's equal to 0. There we are. So now we've got it all in integer form. Lovely, lovely. Okay, but alternatively, yeah, if you are struggling to spot what to times by, like the common multiple or whatever, just do it bit by bit. If you're struggling, like I did there, I got rid of the first fraction by timesing everything by 5, then you would times everything by 3 to get rid of the other fraction there, and then you'd get the same result here. But yeah, there we are. Cool. So yeah, that is straight lines again. So again, to reiterate, the main idea really in this section is we can write an equation of a line alternatively in this form here, but you can use any form or any equation you want to. You can use y is mx plus c. I prefer doing that. It's a lot more intuitive to me, but it's up to you. Unless I haven't seen a question that specifies what you have to use, but yeah, but that's the main idea. That's the main idea of this section. Hopefully start to develop your sort of problem solving, the way you can use algebra to work out certain points or equations. So we looked at more I guess more of a step up in the problems that we looked at now. So hopefully you start to understood what we're doing right with all these questions, and how we can use lines and equations to find, again, missing points or gradients or so forth. But yeah, I'm going to leave it there then, so I'll see you next time.